It is my honor to introduce Stephen Wolfram, a distinguished scientist, inventor, author, and business leader. He is the creator of Mathematica, the author of A New Kind of Science, the creator of Wolfram Alpha, and the founder and CEO of Wolfram Research. Thanks to generous in-kind contributions from Wolfram Research, all Math Prize for Girls contestants receive free student licenses to Mathematica, a powerful research tool used by mathematicians, scientists, policy analysts, and other professionals. He published his first scientific paper at the age of 15 and had received his PhD in theoretical physics from Caltech by the ripe old age of 20. In recognition of his early works in physics and computing, Dr. Wolfram became, in 1981, the youngest recipient of the MacArthur Prize Fellowship. Late in 1981, Wolfram then set out on an ambitious new direction in science aimed at understanding the origins of complexity in nature. Wolfram's first key idea was to use computer experiments to study the behavior of simple computer programs known as cellular automata. Dr. Wolfram has a lifelong commitment to research and education. In addition to providing software for a generation of scientists and students, Wolfram Research maintains some of the web's most visited sites for technical information. Dr. Wolfram is also an increasingly active individual in defining new directions for education, especially in the science he has created. I am pleased to present Stephen Wolfram.
I'll bring a friendly Spiky up here with me. Oops. I don't think I'm going to need that, actually.
Okay.
Thanks. That's the logo of Wolfram Alpha, if you don't recognize it. So this seems like a really cool event, and I'm glad to be able to drop in here. My daughter, Catherine, said that the test was really difficult, and I'm really impressed that you all can do things like this. Maybe with lots of assistance from Mathematica and Wolfram Alpha, I might be able to get somewhere with it at least. Well, here's one point I want to make. If you can do things like this, it means there are all kinds of other things that you can do too. There's lots of great math out there to learn. I think there's about 3 million published theorems about mathematics in the literature of mathematics, and you can go learn about all of those. But here's the really neat thing, I think. If you can do something like the test here today, then in the modern world, you're actually ready to start building new math and discovering new things in math for yourselves, which is really fun. I mean, of course, it really helps that this is the 21st century and that we've been able to build things like Mathematica and Wolfram Alpha, which, people like Gauss, who were trying to figure out interesting math things a couple of centuries ago, didn't have. I mean, I myself originally built Mathematica so I could explore things about math and computation and so on. And I have to tell you that it's really fun discovering new things. It's sort of a different rhythm from solving math problems that have been set up to be solved. Once you get used to it, though, discovering new stuff is actually surprisingly easy. It's very satisfying. You run a little program, you figure out things from it, and you pretty much know that the things you're seeing and figuring out have never been seen or figured out by any human before. Well, statistically, I'm guessing a pretty large fraction of you have used Wolfram Alpha on the web, in apps, through things like Siri and so on. Decent fraction of you probably used Mathematica too. I thought it'd be nice to make sure that all of you had a chance to use Mathematica, so I'm happy that we're able to give all of you a copy of Mathematica. What I'm hoping is that in addition to learning to use Mathematica to do the math that other people are feeding you to do, so to speak, that you'll use it to build some new math for yourselves. I mean, my theory is that near every existing math problem that's been set up, there's another problem that hasn't been solved before, and it may actually not be that hard to solve, particularly if you get to use tools like Mathematica that haven't been around for centuries and so on. So I encourage you to try that. You know, in building Mathematica and Wolfram Alpha, one of the interesting things is that we actually end up solving math problems, new math problems that haven't been solved before, pretty much every day. I'll mention just a few that are very recent ones. Here's one that seems incredibly elementary, but actually is not so elementary. We wanted to support in Wolfram Alpha what people call cookie math. You know, somebody has 3 apples, so-and-so has 2 less apples and half as many apples, and so on. The problem is the underlying math is pretty easy. What's hard is to define kind of the linguistic possibilities of how people represent problems like that. But that, in the end, turned into what's essentially a math problem. We think we managed to get a reasonable solution to it, and actually, in the next few weeks, if you use Wolfram Alpha, you can start asking it cookie math problems, and with luck, it will get good answers. If it doesn't, by the way, fill out that little feedback thing at the bottom of the page and tell us what you think it should do. Well, another math problem that we have dealt with, it's actually come up in the last couple of weeks, is the following. We built a thing for Wolfram Alpha to let people connect their Facebook accounts to Wolfram Alpha and do personal analytics, get sort of reports about their life and times on Facebook through Wolfram Alpha using mathematical methods. One of the things that we did was people can make these kind of social graphs of how their friends are connected to each other. So now millions of such graphs have been produced. One of the things that's interesting is those graphs have all kinds of weird, funky, different shapes. So this leads us to sort of a math question. What's the space of these possible shapes of social graphs? What does it mean when they have different kinds of shapes? How can we characterize them? And so on. This is sort of a problem that I think is directly related to your demographic. It's kind of the intersection of teen with math. I'm hoping if people have suggestions about, we kind of have to build this new sort of field of sociometrics of these graphs, because we want people to be able to analyze these graphs better. That's our problem for the next few weeks. So if people have suggestions, we'd be interested to hear them. You can send mail to education@wolfram.com. How about that, if you have suggestions about this? Another problem that we have, that was a recent one, we're building a calculator for things like iPads, sort of a super calculator based on Mathematica for things like iPads. And Mathematica has all these different functions, and so the problem is we might have 4,500 buttons on this calculator. Clearly not a very usable kind of thing. So for that, we have to sort of understand what are the sequences of operations that happen in typical math computations, and how do we use those to sort of generate the right kind of interface. So this is sort of a meta-mathematical problem that is another kind of math thing that is sort of top of mind in these weeks. Actually, we started doing a Mathematica summer camp for high school students who want to learn Mathematica and do an original project with it. We started doing that last summer, and that was the first time when we had a version of this calculator to show. So we did sort of a focus group there about it, and we were amazed what we were able to learn from that group. And in fact, if you live in the Boston area, we're probably going to do another one of these focus groups sometime soon. If you're interested in it, send mail to education@wolfram.com. Well, let's see. So the thing to say, so there are all these ways that people like us get to use math every day. Turns out math is becoming more and more important in the world at large. It's sort of remarkable how many different kinds of things that happen rely on math in some way or another. I think that sort of the world is somehow getting mathier and mathier. The thing to realize is that when you look out at things that are possible and things that have been made algorithmic and things that have been automated and so on, we're only seeing the very beginnings of that today. There are many new things that will be possible. Just because something hasn't been automated yet doesn't mean it can't be automated in the future. And typically that kind of automation means math or math-like thinking. So this is in the years ahead, I'm sure all of you will be able to use kind of the math and math-type knowledge that you have to be able to help with some of what needs to be done and to make all sorts of interesting changes in the world. So I guess I should stop and just say it's great to see so many people enthusiastic about math and able to do math to such a high level. So do go out and do great things with math and the things that you learn from math. Thank you very much.